Today, I want to show you how you can use tools like Airtrain.ai to compare various models, and notably, how can you compare between proprietary models and open source models, and I will explain to you why this is important to do. So, as everybody knows, GPT-4 is really the king. You know, it's the best model, has the best results, it's the easiest to use. Just grab an API key from OpenAI, get started, use their SDK. This is great, okay? Most of the apps out there are using GPT-4, so this is all good. However, it's not all good because GPT-4 is fairly slow. It's a very big model, and even though the inference infrastructure offered by OpenAI is optimized as much as possible, it is still fairly slow compared to other models out there, and it's also very expensive. See here on the right side, it is the most expensive of all the models out there. You can find all this data on artificialanalysis.ai. So GPT-4 is great, but it's slow and expensive. So it makes it a great model to prototype your app. So if you have an idea for an AI-powered app, you probably want to start with GPT-4. It's the easiest to get started. And also, if your app doesn't work with GPT-4, you probably can just forget about it because other models are probably not going to work better. However, as soon as your app is in production and maybe gets viral, gets picked up on Hacker News, whatever it is, then your bill is going to be pretty high. So at some point, you're going to need to start thinking about other solutions. And so one thing I kind of want to talk about is that small models, very small models, can actually perform very well on very specific tasks. So here, there's a paper from Microsoft published last year, I think it was October, about the Phi-1 model. So the Phi-1 model is extremely small compared to GPT-4. It's 1.3 billion parameters, as you can see here in the red box, and it's been fine-tuned on very high-quality data. So they used GPT 3.5 to generate synthetic data of high quality, and they also scraped textbook quality data from the web. And so this model, for its size, performs extremely well. For example, you can see here on the column, the penultimate column, the results on the human eval benchmark, which is a coding benchmark. And you can see that the only two models that beat Phi-1 is at the bottom here, 50.6%. The only two models that beat Phi-1 is GPT-4 and also Wizard Coder, which is the one at the bottom here. And it has 16 billion parameters. So here, what we see is that for a specific use case, so coding, you can fine-tune a fairly small model on a very high-quality data set and achieve similar performance or actually competitive performance with the larger models. So there's a number of papers out there that do similar exercises. For example, there's the tiny models paper from April last year, where they trained extremely small models. So here you can see in the results, you have the first model on the left is 1 million parameter, very small. And what they did is that they fine-tuned model on like children books to generate very small stories for children. And they were able to show that the 33 million parameter model, which is the green column here, performs better than GPT-2 on the far right. It has 1.5 billion parameters. So once again, for a very specific use case, you can take small models, fine-tune them on a high-quality data set, and get very good performance. So if your app is not trying to do a very generic task, trying to do something very specific, for example, extract some JSON out of a payload and out of some text and feed back to some other API, you may not need to use the GPT-4, which is like the most powerful model out there. So basically, when you're using GPT-4, you're using a bazooka to shoot a mosquito. So maybe you need GPT-4 for your app, but in many cases you don't need it. You need something smaller. Okay. So how can we wean ourselves off GPT-4? Of course, it's the best out there, but how can we get away from it? At some point, I believe that every company is going to have to use a whole fleet of small models that are fine-tuned for specific tasks. They're going to probably run them on-prem because those models are small enough to fit on cheap GPUs. And this is going to be the future of AI instead of always relying on GPT-4. So how do we get away from GPT-4? Well, the first thing you have to do is you have to evaluate alternatives. You have to look at other models out there. You have to build yourself an evaluation data set, some test cases, and see what other models out there work well for your use case. So the first step is to start with evaluation. And tonight, I'm going to show you two types of evaluation. The first type is the vibe check. So the vibe check, as the name indicates, you're just trying to figure out roughly, get a sense for how alternative model perform. It's not statistically significant. It's just for you to build an intuition. And then once you have this intuition, you have to move on to the next step, which is batch evaluation, which is to generate large amounts of evaluation data so that you can see at scale which model performs similarly. So let me switch into demo mode. So I'm going to switch to my browser here. So if you want to get started with Airtrain.ai, just go to the landing page and just click Get Started here. And then you can log in with Google. And the first thing that we're going to do is we're going to do this vibe check. So we're going to interact with a number of models and compare how they perform. So here we click on Play with Models. And here we have our playground. And so I'm going to add a number of models and compare how they perform. So first, I'm going to add a Llama 2 with a 7 billion parameter. I'm going to add also another open source model, so Mistral AI with 7B. And maybe I'm going to add a couple of proprietary models. So maybe I'm going to add Gemini. And I also need to add my API key here. It is. And I'm also going to add GPT-4 to compare. And also recently today, we actually just added Phi 2, the new Microsoft model. So I'm also going to add this one. So here I have all my models in parallel, and I'm going to ask a few prompts just to get a sense of which model performed better. So let me bring up my drafts here. So here's the first prompt that I'm going to try. So essentially, write a short story containing 3 sentences about the AI user meetup in San Francisco tonight. So I'm going to prompt my models, so they're all generating content. And so we can see the first results here. In a vibrant corner of San Francisco, AI enthusiasts gather at the user group meetup and so on. This is Gemini. So, it seems like very coherent and makes sense, with laughter and the hum of eager conversation. So I hope later we can have a laugh together. As the sun sets over the Golden Gate Bridge, actually it was sunny today. And then here we have Phi 2, Alice, a regular attendee of AI user meetups, couldn't contain her excitement, and so on. And then a couple of open source here as well. Sure, here's a short story containing 3 sentences. The sun had just set over San Francisco. I actually don't know how they know the weather today because it was actually sunny, and so on. So you get the gist here. We query a whole number of models at once. And I'm going to try a few other prompts just to get a sense. For example, one I often try is the sisters riddle. So essentially, it's a riddle that tests the model's ability to reason. Julia is a girl. Julia has 3 brothers. Each brother has 2 sisters. How many sisters does Julia have? So Julia has 1 sister, and let's see if the models can get it right. So Gemini gets it wrong. OpenAI GPT-4 gets it wrong. As GPT 3.5 also gets it wrong. Phi 2 gets it wrong as well. Nobody gets it right. This is actually quite a hard riddle to solve. Most models get it wrong. In the past, I got Mistral Medium to get it right. So, you can try for yourself later on. Let's try one last example. Let's do some arithmetics. So I'm going to ask the models to evaluate some math expression and see which ones get it right. It's very simple. 2 plus 2 minus 3/4. So Mistral gets it wrong. Gemini gets it right. GPT 3.5 also gets it right, and Phi 2 gets it right. See, once again, Phi 2, 3 billion parameters, gets it better than Mistral with 7 billion parameters. Okay, why? Well, Phi 2 was trained on very high quality data, so that's one difference. And Llama 2 gets it wrong as well. Okay, so this gives you a sense of the concept of the vibe check. You build an intuition by yourself by querying each model individually like this. But once you have this kind of intuition, you need to move on to the next step because this is not statistically significant. You only tried maybe a few dozen prompts. As a human, you can only prompt the model so much. So what you need to do is you need to build an eval data set with ideally hundreds, if not thousands of data points. and then you run those data points through the models. So I'm going to show you how to do this with Airtrain as well. So going back here to the menu, and I'm going to evaluate models. So here I have a form to upload a data set. So I have this data set here on the left here. It's a very big data set of CNN news articles. So I'm going to upload this. I'm going to select here, and then I'm going to configure a bunch of models to evaluate. So I'm going to configure GPT-4 here, selecting GPT-4, set a low temperature, put my API key, and in terms of the prompt, I'm going to ask the models to extract 3 highlights from the articles, and that each highlight should be no more than 2 sentences long. So for example, maybe I'm building a summarization application, and so I want to test how those models do on that. So I'm also going to load up a Llama model as well. So I'm going to call this Llama 7B. I'm going to set 7B here, low temperature, and I'm going to add the same prompt as well, prompt template. And then a last one is maybe going to be Mistral. So let me try adding Mistral. So naming my model here, and then adding the prompt as well. So now I'm going to send all my articles. So I have 100 articles. I'm going to send them to all those models at once. And so I need to evaluate the output. So in order to evaluate the outputs, as you may know, there is no sort of standard metrics to measure just the raw quality of a model. You have rouge and blue that evaluates the capacity of a model to summarize, for example, or how they perform on translation. But if you're, for example, trying to evaluate how rooted the highlights that were extracted in the original data, there is no real metric for that. So the best way to do this is to use another model to evaluate those things. So we're going to use an evaluator model. So another model is going to evaluate those outputs and score them on a scale of 1 to 5. So I'm going to create a few properties. So for example, the first one that I'm going to rate is groundedness. So here's my scoring prompt. I'm going to read it to you. But essentially, it's bigger here. The score describes how grounded the highlights are in the original article. I'm also extrapolating the actual article, and I'm passing a rubric to guide the model to figure out what score to give. So for example, a score of 1, the highlights are not grounded at all in the article. Most statements in the highlights are not grounded in the facts present in the article, and all the way down to 5. The highlights are very grounded in the article. Most of all the statements in the highlights are directly stated in the article. And I'm going to call this groundedness. I'm going to create a couple more of those properties. So I want to test if the model actually returned 3 highlights. So I have another scoring prompt that I'm going to use here to evaluate that. So I'm going to call this formatting, and I'm going to put this score here. So the score describes how many highlights were generated. So a score of 1, less than 3 highlights were generated. Score of 3, more than 3 highlights were generated. And score of 5, 3 highlights were generated. There it is. And so I'm going to also activate those metrics here just to get a sense of which models are more verbose, which models are better at summarization with compression, and so on. Then I'm going to name my job here at the top. AI user group demo, and then I should be good to go. I'm going to start my run. It's going to do a bit of validation, and then it's going to start my run. So this is going to take a bit of time because it has to ingest the data. It has to prompt the models. There's 100 articles to evaluate. Also, those articles have a lot of tokens, so it's going to take a bit of time. So instead of waiting for it to complete, we're going to look at another a job that already ran earlier. And here it is, an example job. This is the result page for this job. So here I have the list of all my articles here, and I can take a look at the individual results. So for example, here there was an article about a stray pooch in Washington State that used up whatever it is, some article. And then here I have my prompts and the final inferences here generated by 3 models that I selected for that job. So I can look into individual results for this data set, but I can also look at aggregate results at the top here with those plots. So in this case, in this past job, I was comparing Flanty 5, Llama 2, and Falcon. And I can see, for example, that the Llama 2 here has the highest score compared to the other two models. So Llama 2 was the one that generated the least amount of hallucinations from my initial data set. Then here I am evaluating for formatting. So which one of those models were the best at generating exactly 3 highlights? So we can see here again that Llama 2 was the best at generating 3 highlights. And then this is the peak for the score of 3, which was more than 3 highlights were generated. So see the other models were sometimes generating more than 3 highlights, but Llama 2 was almost 100% of the time generating exactly 3 highlights. And then here, this was another property that I had to measure how many sentences were generated in the summary to see that if the models were actually following the instructions that I had given it to use at most 2 highlights per 2 sentences per highlight, and so on. You get the gist. These are aggregate metrics across the entire data set, and this is how you do evaluation at scale, how you get a really statistical sense of which of those models perform better on your task. So if you want to do this, I encourage you to build up this evaluation data set. So, a few hundred examples is good enough to get started, and then try to figure out exactly what you're trying to evaluate so that you can define those metrics here. And I encourage you to have very sort of simple and focused metrics. The more you're trying to evaluate complex and wide-ranging metrics, the less performance the AI scoring model is going to be. But this is essentially how you do evaluation at scale, and you can do this with Airtrain. This is free to use for data sets up to 10,000 rows. So this is how Airtrain works. We also do fine-tuning. So, as I mentioned in my introduction, we believe that in the future, most companies are going to use smaller fine-tuned model for specific tasks in order to have cheap on-prem models. And so we can help you transition from your reliance on GPT-4 to an on-prem small model. So feel free to reach out to us if you're interested in that. So switching back to the slides to conclude. So you can get started for free. Use the playground as we saw in the beginning. We have a wide selection of open source models with different sizes and variants, and also proprietary models. We have Gemini and the OpenAI models. You can do, as you just saw, batch evaluation as well, and fine-tuning as well. So feel free to reach out to us. We also have a Slack channel, so if you want to ask questions and get our advice on your particular task. Also, we have a YouTube channel where we post weekly videos on news in the AI world or tutorials to get started and so on. So check it out at Airtrain.ai on YouTube and subscribe now. Yeah, so let's take a look at the form again. So you have, you're free to use whatever data set you want. So either a JSON-L file or a CSV file. So it's up to you to build this data set. For example, use real traffic from your app maybe to build this data set. And then you can choose any of those models here. And for each model, you can select the variant, you can select the temperature and the prompt. So different models sometimes respond better to different prompts. So you can set different prompt templates for different models. And then I presume your question is mostly about the third part here, how much flexibility you have in evaluation. So we have those unsupervised metrics that are very basic, and length, compression, and density may not be useful for your use case, which is why we offer this AI scoring where you can evaluate for almost arbitrary properties. So it can be creativity, playfulness, politeness, toxicity, the model return anything toxic, and so on. So we encourage to really segment very focused properties instead of saying, tell me how this model did. This is not going to work well. But if you are very specific, was this model polite? And then you give out a rubric of scores from 1 to 5. Score of 1, the model was rude. Score of 5, the model was very polite, and so on. This helped the model figure out how the scoring model evaluate your outputs. And the last method we have is JSON schema validation. So a lot of people use models to generate JSON payloads, but not all models will generate JSON that is even parsable or is compliant with the schema that you require. So you can use the JSON schema standard to define a schema and paste it here, and we will validate all the outputs generated by the model, and we can tell you which of the models perform best. For example, I think I have some results here. So this is a comparison of all those models here as to which of the models do the best at generating JSON. So here we can see that Mistral Medium, for example, has 100% pass rate, is the best at generating JSON, and the other best one is GPT-4. So this is the last method we have. We offer a way to upload your own inferences. So here in the forum, if you want to evaluate a model that is not present in this list, you can do custom model here, and we will assume that you have uploaded the inferences as part of the input dataset. So we're not allowing you to load any open source model because different models require different serving infrastructure. So we can't just serve any arbitrary model. We're not Hugging Face. But we let you upload your own inferences if you want to evaluate them. And if there's a particular model that you want us to support, feel free to jump into Slack and reach out to us. Yeah, so this process here that I showed, you should do it on your eval set. So let's say you have a data set of let's say 1,000 entries, and you're using maybe 900 of those to do your fine tuning, and you're setting aside 100 entries for evaluation. This is where you should use this data set for. So you should not use any of the training data, obviously, to evaluation. Otherwise, you're skewing your evaluation. And this is how certain models end up at the top of the leaderboards. They train on the evaluation set. So here you should upload only your evaluation set. In the future, we'll provide also a similar form to do fine tuning when you can do your split as well as part of the flow here. At this time, we actually are using GPT-4. It is the best out there, as I made the case earlier. And we are using GPT-4 on Azure, which is a little bit cheaper for us. But it is still the best model for arbitrary evaluation. We are going to provide soon models, smaller and faster models for specific things. So for example, if you want to test for toxicity, we are going to provide models to test for toxicity or for groundedness or things like that. So if you want to test for a specific case, you can definitely fine-tune a smaller model to do that. But if you want to be able to test for arbitrary properties, GPT-4 is still the best out there. We do have our own chain of prompts in the backend that takes your own description of the property that you're trying to evaluate, and we set it in our own prompt template that essentially guides the model to generate a score from 1 to 5 and to be consistent and so on, so that we can generate those plots. It is open source, and they just changed their license to MIT a couple weeks ago, which means that you can use it for commercial use cases. However, I would encourage you to do your own homework and do some evaluation because it hasn't been fine-tuned for instruction following. It hasn't been fine-tuned for human preference. There are some fine-tunes out there. There's a DPO fine-tune that essentially is equivalent to like RLHF for better results. But for example, for toxicity or things like that, I would encourage you to test it and not just blindly put it out there. But it's a very promising model that is worth looking at. So for example, you could have an eval scenario where you have a data set of 100 entries and all of the entries are the same, which means that you're going to prompt the model 100 times with the same inputs. And you can have some eval property to see if, on average, the model is consistent in terms of what politeness or creative or whatever you're trying to generate. For example, the other day I was trying to test how models perform at generating random numbers. Actually, I may have the job somewhere here, random number selection. And so I think I was, so essentially I used this scoring method to see what was the numbers that were being generated. So a score of 1, the model selected 1, a score of 2, the chatbots selected number 2, and so on. And as you can see, there was a huge bias towards the number 4, which is very interesting. And I actually saw the same during the vibe check. I was asking the models to generate a number from 1 to 5, and very often 3 and 4 came up. So models are not very good at generating random numbers, ironically. So you can use this tool in very different ways like this, not necessarily just to evaluate on different inputs, but for example, to generate arbitrary content like a random number and evaluate the outcome. So the reason why we have a limit on it is because this tool is free. And so obviously, if somebody uploads a data set with like a million entries, then all our GPUs are going to be heating up for this one user and other users are kind of left in the dust. So this is why we have this limit. If you have a use case for larger data sets, we will be happy to accommodate you. Feel free to come and talk to us. But in general, what we saw is that, with a few thousand entries, you already get a sense of how the model performs. So we don't have error bars on those things because obviously these are scores that are generated by an AI model, but it's rare that you need more than a few thousand entries to get a sense of how your model performs. It is true that if I go to the playground, if you add any of those proprietary models, we ask you to add your key at this time because those models cost money, and so this tool is free, and so you're adding your own key. It's a pretty common pattern. Many tools out there that rely on, for example, GPT-4 will ask the user to add their key. We have been thinking about potentially asking the user to add a payment method instead, so that we can basically forward the cost from that we have to pay for Gemini or GPT-4. We launched this playground yesterday, so we haven't built that yet. But if it's a problem for people to get API keys, we would be happy to do that. The GPT-4 API keys are fairly easy to get. The Gemini API keys are a little bit harder to get. We actually have a blog post on the website to explain how to get those keys. But at this time, yes, we are asking people to bring their own keys. The best answer I can give you is that when you have I'm going to bring up this example again. Let me make this a little bit bigger, a little bit smaller so that we can. So here you can browse through your entire data set and look at individual examples. So for example, this entry number 8, here are the values for the AI scores for, groundedness, formatting, and so on. And then you can dive deeper into the actual inferences that were generated for this input. So we don't quantify explainability, but you're free to craft your own scoring properties to kind of extract this information and then browse through your evaluation data set and look at examples one by one. In the future, I think we will also like to add some feature where you can click on certain values here in the plots at the top, and it will segment the list of inputs for the inputs that are in that bucket, so that you can click the low performers, for example, click here on score of 1 and see all the inputs that were performing poorly on this score. But yeah, that's as much as we have at this time.